restart. So we've been taping these.
Yeah.
Okay.
Oh, wait,
You're-
one thing, wait. Let me hand out the sky calendars. John does our Sky Watchers, Oak Creek Canyon sky map. And if we don't have enough, let me know, because this, or check your Mountain Messenger, because this is the 1 month of the year that the sky calendar from Abrams Planetarium is on there for free. You can download and print it. Normally, we pay like 22 cents a copy to print these and give them to you, to the Abrams Planetarium. And then John's is free, and that's on our website.
Yeah, I haven't put it on the website yet, but it'll go up. And you'll notice on this thing, this month, or May, not this month, but May, is International Space Station Month for us. There is not one iridium flare on that list because there are some nights, some days where we can get, and I'm challenged now to go find these things, because some of them last for like 20 seconds right along the horizon. But there are some days where there are 5 passes. 3 in the morning, 2 at night, 2 in the morning, 3 at night. So amazing. So no iridium flares on the list this month, but looks like lots of great International Space Station passes. How many of you guys seen the space station go overhead? Oh, well, we tried to go out last month, but it was cloudy. Tonight it's cloudy, unfortunately. So remember, get to also, if you have questions, I follow this stuff all the time, but it's really hard to keep up. And so if I don't know it, we'll find out. But I will try to answer all your questions if we've got them. So this is going to be a combination of what Leonard does and what I usually do with space news, which, manned space program, stuff like that, Mars and planetary stuff, with some of the stuff that's going on in astronomy. And you would think there's not a lot, but there is. And so we'll just dive right in. Tomorrow, we hear all this stuff about SpaceX doing their amazing thing. We forget that Jeff Bezos and the guy from Amazon has Blue Origin, and New Shepard is a suborbital vehicle. They're going to launch tomorrow. This will be the 8th launch, and it lands just like SpaceX's Falcons. And so they're trying to do the reasonable thing. So watch for that in the morning. It's going to launch. I didn't get the time, or I don't remember the time. But if you check it out, it's sometime tomorrow. One of the things that happened this week was that we're trying to send a Mars mission in 2020, in 2 years, and they've been testing the heat shield down in Waterton Canyon at Lockheed Martin. They're putting stresses on this thing that are about 20% greater than what they would see at Mars, but they cracked it. It doesn't affect the mission at all, but I thought it was an interesting news item for this group. So. Yeah, and especially since they're testing it here in Colorado.
They had built a whole new one.
What was that?
They had built a whole new one.
Yeah, well, they will, but it's apparently it's not going to impact the timeline. So that's a good thing.
What's that made out of? Is that new pica material?
The Pike is old, but that's what it is.
Well, newer.
Is it a different shield than Curiosity used?
Yes.
It's the exact same one as here.
Oh, I thought it was, yes. It's the same one. Thanks, Bob. He's our resident guy. And I'll have.
You're on a roll, man. Keep going.
Oh, no. Bob and I were talking about this earlier. This resource prospector, this mission, the Trump administration has been all about going back to the moon instead of Mars. They've brought it back. And this mission was mainly, it was going to land near the poles and then send this rover out to look for water ice. Water is very important for us. I get pretty thirsty, especially when I am on the moon. But this mission's been canceled in favor of some other things, and which is weird too, because NASA's got a boost in their budget. So, and we'll see what happens with the new administrator that we got. Oh, that's in a second though. One thing that our Congress is doing is passing some new resolutions. This only passed the House. This is a House Resolution 2809. I used to work at a company called Space Imaging. They do images for Google Maps is what you normally see, these high resolution satellite images of Earth. And this company, Space Imaging, was created along with another company called Digital Globe, which now owns everything. Everything's Digital Globe. But back in the Clinton administration, he signed a directive saying that it was okay to declassify this high-resolution satellite imagery, create the commercial satellite imaging market. We're talking spacecraft that can see this table as a pixel from space, from 280, 300 miles. It's pretty amazing stuff. That's the declassified stuff. I don't know anything about classified. Don't ask me. But anyway, so this would actually, right now, it's the licenses for this are handled under NOAA, the National Oceanic and Atmospheric Administration. This new Enterprise Act will create an office called the Space, oh shoot, I forgot. See, here it is. I load my brain up and then it all goes to whack. But creating a new office, everything will be run through this bureaucracy, and so it'll streamline things, because right now, a lot of these companies, and not just the big companies, Digital Globe or those, a lot of smaller companies who are sending up CubeSats fall under this category. And so streamlining this process to get these things in orbit much better, faster is important. And I have to ask, there is a ton of us tonight. Are we comfortable? Can you guys hear me okay?
Yeah.
All right. I'm not using the microphone, but I can. I use my dad voice. That's what my wife.
You're really loud, you're okay.
I'm really loud.
You're perfect loud.
Here it is. Jim Bridenstine. He's our 13th NASA administrator. He was sworn in this week. He's been in the pipeline for a while. The Congress made him jump some hurdles. This guy is a military pilot. He is a congressman, so he's the first political appointment for a NASA administrator. Usually they've been scientists, or at least in that pipeline. He is not, he's a space enthusiast, and we'll see how he does. But we have a new NASA administrator now. See how he does with moon stuff. And here's this one thing. I thought we already did this. We look at the Earth all the time, I thought. But a privately owned company backed by Bill Gates, Airbus, SoftBank, and this other rich dude named Doug Weiler, they've created this company called Earth Now LLC, and they want, really what they want is a global surveillance network. I mean, we're talking not just what the Digital Globes of the world do, but also, they would like to do real time, looking to see, for human trafficking or pirating, things like that. So a surveillance network, this is a pretty far out image from a GOES satellite. I think they are creating a constellation, they want to create a constellation that's much closer to Earth with a lot, and they want to make it so it's public. So you and I can catch the bad guys. That too. That is the worry.
Is that good?
Is it good? I don't know. I threw it in here so you guys will be aware that this is in the works. So, we'll see. This week, earlier in the week, the European Space Agency launched Sentinel, which is a new Earth observation satellite to study the seas, land, and air. This was launched out of Russia on one of their rockets, so lots going on still. I'm going through a phase, not a phase, but I'm going through a section of slides that there's a lot of launches going on this year. Holy smoly. And so far, China's has their 12th launch of 2018. They launched a couple of, 5 on this rocket, Long March 6. They launched 5 little satellites that are they're all Earth observation satellites, science satellites for the Chinese government. But the 12th orbital launch. Now, you remember Leonard talks about the Chinese space program. It's something to watch. They are on track to get to the moon. And these launches just help refine their capabilities to do that. So this is just departures in May. I couldn't even find the numbers for how many so far. I didn't count it up, but we've got, May 2nd and 3rd, China, and Atlas V. It's going to launch InSight, which is another Earth observation satellite.
Mars,
Oh, sorry, Mars. You're right.
Mars lander.
So this is an important one to watch. Sorry, I don't know what I was thinking. May 7th, the Falcon 9 launches with some
They are.
smaller satellites. The Falcon 9s are the SpaceX re-landing. The smaller rocket's not that huge one. This new launch facility is coming up in New Zealand. They're going to sometime this month launch an Electron rocket from Rocket Lab. This is a new company that's just trying to do some stuff. Haven't heard much about them, and I couldn't find out much about them to answer any questions you have. So we'll just keep an eye on them.
It's in my book, though.
What are they? Are they government, are they private? What's
No,
their-
it's
It's a
private.
private.
It's private.
So it's like imaging or telecom or
Small.
internet?
They're basically want to be cheap access to space.
No matter what you wanna do,
Yeah,
they'll
yeah.
get you there, okay.
It seemed, from what I could find, it was a lot, not the CubeSat specifically, but like
Lots of nanos. Yeah.
like now little satellites. Yes.
Yeah, they're experimenting, they're actually using electric motors to
Mhm.
run the turbo pumps
Yeah.
for the rocket.
Interesting stuff. SpaceX so far is on track to launch 28 times this year.
Jeez.
28 times.
So what's the impetus behind all this? All of these launches, all compressed in a small period of time?
Well, I guess what I was trying to get at was that it seems to me that the pace of rocket launches, are most of these are, well, the Iridium and then Terry's rocket out of Wallops that'll deliver a science payload. These are mostly science missions. I didn't even include the DoD stuff that's being launched. And what's interesting to me is this Atlas V being launched out of Vandenberg and the Iridium, the Falcon 9 out of Vandenberg. Not everything's happening at Wallops, which is up in South Carolina, North Carolina area. Or is it Virginia? Virginia.
Yeah, or
So-
Canaveral.
Yeah, they're not all at Cape Canaveral. So it's being spread out a lot more. And it seems kind of interesting to me that they've put this launch facility in New Zealand because the farther south or north you go, the more fuel it takes to get into, well, unless you're going to a polar orbit, but if you're trying to get into any sort of regular orbit, it takes a lot more fuel. So a lot of launches have been happening out of Brazil at those for area. So
Where's Vandenberg?
in California,
Yes.
and it's right on the ocean, so they launch out over the ocean to the west, whereas at Canaveral and Wallops they launch towards the east out over the ocean.
So John,
Yes, sir.
these do polar orbits from Vandenberg.
Yeah, yeah.
So how come they can get this Mars craft? They have to be shooting as far east as they can without hitting LA, you know?
I don't know why they picked Vandenberg for the InSight mission.
Yeah.
It's rocket science, man.
Well, I know it. I mean, they figured it out. I mean, it's going to work, but
As long as you're on the equator, you get the biggest Earth boost you can
Right.
from the rotation of the planet. So where you are on the equator really doesn't matter too
No,
much.
but at Canaveral, you can go east mostly, you use that with you. At Vandenberg, it's mostly for polar orbiting. So
Yeah.
an airplane can launch is very unusual.
It
with
has to
Vandenberg.
go
So
over the ocean.
It has to be that they're willing to launch it south and have it probably go south of the ecliptic and then come back up and come to Mars. That's just
No, I've
how I
launched
feel.
4 NOAA satellites from Vandenberg and they were not polar.
Okay,
I don't know, we'll talk.
okay.
You can do a lot of stuff in
That's
there.
rocket science, yeah. John, how can SpaceX be doing 28 launches?
they are set
That is
for it.
astounding.
So their original schedule is one every 2 weeks, and they've got this down to like 9 days now. And we're not talking, I don't know. I think they're, go
It's
ahead.
an assembly line. I actually visited their plant a couple months ago, down in West LA area, not one of the better areas. Hawthorne, there you go. And it's a total assembly line. I mean, great technology. It looks like a terrible place to work. It's like working at a Ford facility, you know? It's kind of crazy, but they're actually on track for 2019. They're expecting 40 launches, and they're building to that pace.
And what astounds me about this is that they have the business. Right? It's not that just they can make the rockets that fast, it's that they have customers.
Yes.
Provide a cheaper launch,
cool.
everyone wants something up there.
That 28 launches is a third of all launches in the world this year.
In the world?
In the world. Only about
So you-
90 launches here.
Yeah, this is why, to me, it's really picked up in the past, since space action. Yeah, yeah.
And if you look at the heavy, that's 3 of those Falcon 9s strapped together. So that'll just ramp it up even further to get more up there in one shot. It's crazy what they're doing. It's,
Well, if you look at how often the Russia's launching missions, I mean, they're like every 6 weeks or something like that to the space station. And they've got it down, and so SpaceX is just coming on board with this stuff. So again, back to the Chinese spacecraft, CNSA is the Chinese National Space Administration. I'm sure that has a, anyway, they're gonna create a relay satellite that's gonna orbit the moon. Actually, it's not orbiting the moon, they're gonna put it in a spot called Lagrange Point 2, which is about 60,000 miles from the moon. And it's a stable orbit. I mean, they can put it there, park it, and not use hardly any fuel to keep it there. And so they're gonna use that, this Chang'e 4 is going to the far side of the moon. This is part of their going to the moon mission. And they need a relay satellite. Obviously, we can't see the far side of the moon, which means we can't talk to them. This relay satellite will help with this communication. This Cao Bridge of Magpies is based on a Chinese myth. And I love these things. So in Chinese myth, these magpies went wing to wing to bridge a visit between a princess and her husband, who is on the other side of the Milky Way, on the opposite side of the Milky Way itself. And so it's an interesting poetic name for this program. But again, this will launch later in the summertime. Earlier this month, SpaceX Falcon 9 launched TESS. TESS is I can't remember what it stands for off the top of my head.
Exoplanet, something sort of.
It's gonna replace Kepler, which is just about, if it's not out of fuel, it's just about there. Kepler's been the boon for exoplanet discoveries in the past couple years, and TESS will further that mission even more. And they launched earlier this month. Big deal for SpaceX to launch this thing.
over 2,500 exoplanets found.
And that's just looking at a tiny little piece of sky. It's just incredible. We'll see if we can get this to work. This was a close-up. This was the astronomy picture of the day. It was a really long picture, but I love John Krause took this picture. And it's just, I love that. It looks powerful to me. I can watch the Saturn V launches over. Jupiter. Juno's at Jupiter. And this was released it was taken in January, but it was released last week. Just incredible. Now, remember, this is not real color. These are, they've emphasized some colors. Juno's not necessarily like Galileo or some of the other ones. We put cameras on them to get really nice pictures back. Juno's, we have to cheat a bit more, and it's also showing more, not so much in the visible light, but into the infrared range more. And so that's why this kind of looks more detailed, because there's some heat going on in this image. And, we get this amazing picture of the red spot. I just had to use some eye candy. And here's some more eye candy from Curiosity. This is a picture looking at Mount Sharp. Well, I don't think it'll get up to the top, but it's heading toward Mount Sharp. This terrain that it's traveling over, they're very interested in because it seems to have been deposited in a watery environment. They're clays, and so NASA's keen on getting across this and checking it out as much as they can. We're on Sol 2034. That means 2034 days on Mars. And this image I got from yesterday. I do not know the scale. Those big boulders could be this close or across the parking lot. I have no idea. And they don't have a, ruler sitting out, and there was no information, it was just a,
So, I mean, how do they stay up there? What do they eat? How can they cover the entire planet? There's just a lot of questions, but it's an exciting idea.
well, some of the interesting things they've been proposing is, there's a weird, Mars has darkening that isn't easily explained, and they're saying, oh, maybe it explains that. They're reaching, but and it's going to cause some discussion. I think that's a good
John,
thing for some.
explain Sagan's razor versus Occam's razor. And that says it. No, do it. Seriously, say it. Do you know the difference?
I've never heard of Sagan's
Okay,
razor.
So this is an old joke of planetary science, and this is what applies here. So Occam's razor, you guys have probably all heard of. When there's two competing hypotheses, you choose one that's more simple. Okay, choose a simpler idea is usually right. Carl Sagan made a lot of great contributions to planetary science, but he was a very speculative person too. So the idea is Sagan's razor, given two hypotheses, you choose the one that's more interesting. That's exactly what this is.
Moving on. Talking of Kepler, this planet called WASP 104b. This planet is what's called a hot Jupiter. It's around a small yellow dwarf star. It orbits every 1.7 days around the star. And it absorbs 99% of the light that the star gives off. Now, it's tidally locked, which means that there probably is no weather on this thing, so there's no clouds to reflect light back into space, and it's probably they've detected potassium and sodium, which are very, they absorb light. And so this is why this is. Hubble captures, this has been we thought that maybe some supernova occurred because of a companion star creates, spools off material and then blows up and it obliterates the system. And Hubble actually found a surviving companion. Now this is from a picture from a galaxy about 65 million light years away. So it's not very close, but still pretty significant in the world of astronomy. In this little tiny dwarf galaxy, we've discovered hardly any dark matter. Now dark matter is the thing that they think the universe is mostly made of, like 85%, but we can only detect it through gravity. We can't see it directly. This little galaxy, now these little peppery things is a galaxy. These are galaxies that are way behind it, which I think is cool in itself.
So
And then-
John,
yes, sir.
Sorry, this is like
No.
cool. Does that mean that basically the stars are all moving in a way that's perfectly consistent with gravity? So there's nothing weird going on. That's why they say there's no dark matter. Okay.
Everything sort of goes to the
Whereas-
Newtonian physics.
Whereas if you look somewhere else, it's like it doesn't move right.
Well, it moves differently than we would predict if with,
Okay.
but then you throw in the dark matter, everything works out. And so that's, I mean, it's sort of like one of those, well, there must be something out there because the stars aren't moving exactly the way they're supposed to.
It's not moving in a Keplerian way that you would expect from a dark matter.
Okay.
And speaking of gravity, we've, Hubble, they've got new lenses on it after this last mission 5 or 6 years ago to put a new telescope in. In 2011, we took a picture of this galaxy that's being distorted through gravitational lensing. There's something in front of it that's distorting the light so that we can see it on the other side, and it magnifies it just like you would a magnifying glass. In 2011, we couldn't see anything right there, but since we see this dot, and this is what astronomers think is the farthest star they've ever seen. This thing is 4.5 billion light years from the edge of the beginning of the universe. That means it's like 9 billion light years from us.
So what's the name of it? Number of it?
I think we should, let's come up with a name. If you're bored some night, some things I found. Eon.co has got this this series called Majestic Earth, talking to astronauts and their experiences in orbit. The Greatest Leap from Ars Technica, these are websites you have to go visit. Greatest Leap is is concerning with the moon landings, Apollo 11, Apollo 12, 13, 14. And then, I don't know if you've seen them on National Geographic, One Strange Rock. It's been an interesting show.
So, John, could you put those on our website and
Sure.
maybe send them to Carolyn to put on Facebook?
So, real quick, I'm going to go through these quick. I had a chance to go to Washington, D.C., and I was there while the cherry blossoms were going. And, you know, they're pretty cool, but I had a dream that I was there at night with the Milky Way shining. And well, that's the first time, by the way, that was the first time I'd ever been to the Jefferson Memorial. And so, this is my dream.
Your Photoshop dream, right? Come
Let it
on,
be a
I live
fantasy.
there. You don't see that.
Yeah, the lights would have to go out. But Barb, she wanted me to put these up. So. But, you know, so my real reason for doing that image right there is this is my favorite sci-fi book cover from Michael Whelan. Does anybody know the book? Yeah, Foundation's Edge. So, sorry. I took so much. So you have to ask some questions while we change some things.
Yeah, thanks.
Questions? Yes, sir.
Yeah, 2 points of order. Tomorrow's launch of Blue Origin, the launch window starts at 7:30 a.m. our time.
Oh, it's early.
I knew it was in the morning, I just couldn't
It
remember.
will be live streamed, so Google it and you'll find it.
Yeah.
Yeah, get a good
And
cup of
the other
coffee.
thing you said that the Sentinel-B launch was from Russia and it's actually from French Guiana.
It was?
Yep.
Thanks, French Guiana.
And actually, Blue Origins, I looked it up while you were talking, it's kind of interesting, they've launched 3 vehicles. The first one crashed, didn't make it.
Yeah.
The second one, they reused 4 times afterwards. Tomorrow's launch is a reuse of a launch that was in December of last year. So it's the second launch of the same vehicle. So it's really
These are all
cool stuff.
suborbital, but it's really smooth.
I have no idea. I looked up at a 3-paragraph article, that's all I know.
You're ahead of the curve from us.
Suborbital.
Because they're shining.
Turn the mic on for Carolyn.
Oh, right.
Just turn up the
Got it?
volume,
Yeah.
the mic volume.
And just before Carolyn starts.
Where do you turn it up?
Oh, right here. Yeah. You want to try that?
The mic volume.
Wait. I don't know. Wait. Try that.
We're professionals here.
Yeah.
Professional grade.
Whoa. I can play with that a bit. Yeah, I just wanted to make sure you knew that Carolyn, you know, she's giving this talk based on her book, which is for sale back here. And I highly recommend it. I haven't read it all yet. She gave me an advance copy. But she's such a great writer, and it covers so much. It's, wouldn't you say, well, you'll explain it, but a really great reference, and not, oh, you didn't want me to say it was a reference point too, but it just covers so much of space exploration that past, present, and future, as the title is, and highly recommend it, and she'll sign up for you. And,
Yeah.
it's a, you know, it should be a tax deduction for you guys because you come to Skywatchers. No, but and I just also wanted to mention that you know, we, as if you're new to our group, you know, we have a wide variety of knowledge base here. We've got people like Rob Osborne, who builds satellites, and we have astronomers and astrophotographers and planetary scientists and everything. And we also have Robert Zubrin here and his fiancée. And he'll be one of, I hope, one of our future speakers, hopefully this summer, on Mars or the moon or anything you want to talk about. Do you want to say a few words? Just
Not really.
okay.
I greatly enjoyed the talks here, and I'll be happy to give one myself. It'll probably be about the human exploration of Mars. And we'll try to find a time this summer to do it.
Great.
All
Okay.
right. Before I get started, can everybody see the screen without reflections on it?
Yes.
Okay, good. We're just trying to make the lights so that they don't shine right on it.
I can see it with reflections on it.
Oh, if you turn it off, is that going to mess up your
Okay.
filming?
Nope.
Okay.
Yeah,
All right.
it's, yeah.
All right, well,
Yeah.
as Barbara has pointed out, yeah, I'm really pleased to be here. I gave this talk about 4 days ago at Denver Starfest. If any of you have ever been to that or heard of it, it's started out as a Star Trek convention a few years ago and is now sort of science and science fiction and a number of different things. And I ended up bringing some speakers out from NASA and Lockheed Martin and places like that. And we all gave science talks, and this was one of the talks that I gave, and then I went and updated it this week for you guys. So one of the things that I've been thinking about for a long time, probably since I was 16 or so, was the fact that we've been sort of this spacefaring race for a long time. We've been in the space exploration business for about 60 years, technically, when you talk about the first space exploration rockets that went up. But humanity's interest in going out there stretches way back across many centuries. And that's partly what I want to talk about today is that interest and how we've used that interest to build a spacefaring civilization. So our interest in going to space has got a lot of roots. And I put together this little list of roots, which I probably won't get through all of tonight, but that's really what the book is covering. And so we have history, we have cultural structures such as law and education and things like arts and sciences and technological development, commercialization of going to space. And I'm going to make this a little bit bigger so I can see it here, so I don't have to keep turning around. And then in addition to all of that, we have the commercial participation, which has been a big thing, with SpaceX and Blue Origin and Arianespace and all of the people who have been involved in building launch structures, from Lockheed and Boeing and all of these, for many, many years. So there's been this commercial component that we sort of know about, but we sort of don't know about. And then we also have the future. We don't just have all this stuff that's gone on in the past and what's happening now, but we have the future. And the reason I really got to thinking about all of this was much harder. It was about 2 years ago I was approached by a publisher in England called Amberley Press, and they wanted an overview book on space exploration. Now this is the kind of group that, if you go look at their webpage, it's AMBERLEY, and they do things like very interesting little books on barges and aircraft and trains and transportation related things. And they've recently branched out to do a little bit more. They've got a couple of things on industrial expositions in different parts of England, since they're in England. Well, they contacted me and said, we really would like to move into space, and we've never done space before. And so we batted the idea back and forth for a while about, what kind of, how deep do they want to go with this? And I wrote back and said, well, how many words do you want? That'll tell me how far I'm going to go. And they said, well, we want the entire history of space exploration in 100,000 words. Is that too much? And I'm thinking, you could tell the story of Gemini in about 100,000 words. But to really do it right, you'd have to write an encyclopedia, and that's not what they were paying me to do. So I had a limit of about 120,000 words, and that's including all the back matter and everything. And what they wanted me to do was make sure that we could use the book to acquaint people with the basics of space exploration, the history of it. So, talking about rockets and all this sort of thing. And particularly for people who are interested but don't know they're interested, or they think they're interested, but they don't want to know about every rivet, the size of every rivet on the side of the Space Telescope. Not that level of detail. So that's what I set out to do. This is the book, and there's copies back there. You don't have to buy one, but if you do, that'll help you buy gas on the way home. Available at bookstores everywhere, and came out in the United Kingdom in November 1st, I believe, and it came out here on the 1st of April. I decided that the book would answer the question, after batting around with these guys, what does it take to build a spacefaring civilization? And that way I could get into history and all of the other things that I've talked about. So for this talk, I'm just going to focus on a few of those, because if I did the whole thing, I'd be reading the book to you. But that's why you get to buy it and take it home. So, the first thing that I want to talk about is rockets, and not in a lot of detail, but just a little bit of history. And the first question that I had to ask myself as I'm doing my research, and there's a lot of really interesting stuff that you can go read about, is how do you get from this to this? And how long does it take to get from that to that? There's well over at least 1,000 years of history between this and this. Rockets weren't just a 20th century invention like we all sort of grew up thinking about. I mean, any of us who have launched pop bottle rockets and Estes rockets, we kind of know that this happened long before. But it turns out rockets go back a long ways in human history. And of course, the first ones were actually more like fireworks than Saturn V's and Falcon Heavies and that sort of thing. So this is a drawing of what of what I've been able to find as the first thing that we could call a rocket. It's called a fire arrow, and it was first invented in China around the year 900. Now, there are some people who disagree with that and think that they were actually around earlier. There are some scholars that say that similar things were around as early as the 1st century AD. What they basically are tubes of material filled with gunpowder. The Chinese say that they invented gunpowder. I probably believe that. I don't have anything to not believe it. But there are people in the Middle East who say they did too. So it's possible there was trade back and forth. Gunpowder existed, and they started stuffing it in tubes and lighting it off just like 13-year-old boys do all the time. Yes, and some girls too. So these flaming arrows go back a long ways, and they basically were using these bamboo tubes to propel things. First it was just to scare the crap out of their enemies or to send messages or whatever. But the designs, they started improving on the designs, and the first true rockets that you could really call rockets really appeared around the year 1252. Now there are writings in China about how these things were invented for war. And it seems like a lot of our space exploration material is really made for war. We apparently like to have war. So as with most wars, the enemies of these people that were shooting the fire arrows at them grabbed them, took them back, and then they started copying them. So there's some complaining in the Ming Dynasty records about the people complaining that the Mongol horde stole the idea and then started shooting their rockets back at them. But by the 1400s, warriors had invented a sort of mobile rocket launcher. They had fire arrows that they were using quite a bit, and then there were similar weapons that were being built. Basically, the more you could do with this gunpowder in these tubes, the better. And these weapons spread throughout Asia and into other areas like the Middle East, also into Europe. Of course, the Chinese didn't use these early rockets just for war. They also used them for fireworks, and that was a very popular way to celebrate things. This is a copy of a Ming Dynasty woodcut showing fireworks. That little tree-shaped thing up here is a fireworks display. And so and we get fireworks displays now from the Chinese as well. So this is the member of the royal court watching a fireworks display. Okay, come on. Here we go. So rocket development continued, as you might imagine. Anybody wants to have a really good set of rockets, they're going to keep building them. This thing on right above me is artillery, and it was created through, I'm trying to read this. It's a Chinese weapon that was made it's basically been written about in the Ming Dynasty. They wanted bigger and bigger rockets. They wanted more things they began to look more like cannons. The thing on our right here is also a cannon. It was built in 1586, and it was built in Moscow, and it was built for war as well. So this is, again, all powered by gunpowder, plus now projectiles to go out and deliver a bullet to the enemy. It wasn't really until the 17th century that the scientists figured out the laws governing rocket flight. So, you could put these things and you could fly them, but you really couldn't control them all that well. It's kind of like early drones, you really had to stabilize them and make them fly the way you wanted them to. But these things, they really didn't have the vanes on them at first and the guidance systems that we had. They really had to sort of look at Sir Isaac Newton's work and his laws of physical motion to figure out, if we want to make it go like this, we have to build it like this. And of course, parallel to the development of rockets, we also had the development of flight. And so you see people like Leonardo da Vinci, for example, creating his endless drawings of wings to be able to have people take flight. The development of rockets remained pretty experimental until the late 1700s, when the very largest ones began to be used for war. And they were used against the British by the people of India. And if you recall your history, Britain had basically taken over India and was lording it over it as a colonial power. And the Indians were lobbing these things at the British, and they were really doing quite a lot of damage to them. So that led Sir William Congreve and he was a British military officer, to create this rocket called the Congreve rocket, and that was in 1813. And you can see it's got a little bit of guidance material up here to help it fly through space a little bit, fly through the air a little bit more safely. Now, as time went by, other people began to introduce more stabilization to these rockets, and it looked like things were going along really well, but they really kind of fell out of disuse for a while, and people were really starting to develop more things like artillery cannons. Here we go. No, that's not what I wanted. Back here. Oh, I didn't put in the artillery. I had a really cool picture of an artillery cannon. It was really cool from about the 1800s. We're going to skip on up to Konstantin Tsiolkovsky now, because he's really sort of the father of modern rocketry, and that began in the late 1890s in Russia. When he published a report suggesting that liquid-fueled rockets, instead of gunpowder, let's use liquid-fueled rockets, send these projectiles farther and farther, towards the enemy or whatever. And so he's been widely thought of as the father of modern rocketry or modern astronomics. So about a decade later, we had Robert H. Goddard creating his liquid fueled rockets. You've probably all seen this picture there for a while. He's like the god of rocketry around Worcester, Massachusetts. Eventually, people got really tired of him dropping these things in their backyards, and so he took them out to New Mexico, started testing them there. Now, the interesting thing about him was everybody's taking rocketry seriously. He's taking it seriously. Tsiolkovsky is taking it seriously. We've got Hermann Oberth starting his first work, and I'll get to him in a minute. The United States wasn't taking this very seriously at first. Goddard was trying to get the military interested in this. He applied for patents. He got patents on all of his military rocketry, but they weren't really very interested, and he was actually mocked by the New York Times. They wrote an editorial saying, of course, nobody, this is really silly. We're not going to be sending rockets to space. Everybody knows you can't push against anything in space, so how would a rocket work? Think about that. That is the New York Times telling you that. When the Apollo mission left, the New York Times finally retracted it. It took a while. Anyway, eventually the military did get interested in the use of rockets, and Goddard ended up with a great many patents that his family then carefully guarded. And at the same time, the Russians started getting very interested, and the Germans started getting interested in his work. And that led to the next big boost in rocket development, which came really during World War II. And I'm skipping over a lot of smaller developments, but World War II is sort of the big development period for rockets. And of course, we've all heard of the V-2s and the Blitz. All of these perpetrated by the Germans in their conquests during the war. That was all led by rocket experts such as Hermann Oberth and Wernher von Braun, and they created and maintained and perfected the V-2. Now, at the end of the war, von Braun and his people, as everybody knows, some of them were brought over here to the United States to help the fledgling space program here, NACA at the time, build new rockets. The rest of the ones who weren't brought to the United States went to the Soviet Union and basically did parallel developments. Both groups worked furiously to develop these rockets, and even further, they really had the aim of going to space. Although there was a parallel development for ballistic missiles, I'm not going to get into that in this talk, but there was that also that. So now we all really know how it worked out. Between von Braun and the developments by the Army Ballistic Missile Agency, the U.S. created its own rockets for use in space. The same thing was going on in Russia under heavy secrecy. Nobody really knew anything about it. The Cold War was basically in full swing at that point. So during the 1950s, sort of another parallel development, geophysical scientists proposed and initiated something called the International Geophysical Year, which would unite scientists around the world in studying our own planet, the magnetic field, the surface, all these things, the upper atmosphere. And for that, they were going to be using sounding rockets to send things up there, which they'd started doing in the late 40s, sending up sounding rockets to study the upper atmosphere and the magnetic field. Those were on very short flights. But there were also these hints and these rumors going on, about Russia or the Soviet Union wanting to do something. And they actually even, within a few days of their first launch, transmitted the codes that people could listen to little signals from their mission. I'm not sure how seriously people took it here in the United States, because they were totally surprised when the first mission went up. And it was from the Soviet Union. It was the first major launch of the space age, and it was the launch of Sputnik 1, and it was launched on October 4th, 1957. I don't know how old all you guys were, but I was about 3.5 years old. And I remember that, hearing the word Sputnik and stomping all over the house yelling, Sputnik, 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 until my parents were like, take her outside, show her the damn thing, get her to shut up. And the daddy took me out and he showed me this thing. I had no idea what it was, but I saw Sputnik. They beat the United States. They used an R-7 Semyorka missile, which was developed from the design of the V-2, and it was basically the beginning of the space race between the U.S. and the Soviet Union. As a result of this launch, several things happened. We already had a space agency. It was called NACA, and movement was afoot to turn it into a civilian space agency, which eventually became NASA, and that was to further our country's goals in space, one of which was to send humans to the moon. But first, the U.S. had to have successful launches, and I think most of you who are of an age can probably remember the many unsuccessful launches we had, testing our rockets and seeing them fall over and blow up. Eventually, we got one to work, and that was Explorer 1, which was launched into space by the U.S. Army aboard a Vanguard rocket.
Jupiter C.
Jupiter C, right. So that went up, and this isn't good, okay. Space race starts, the next big thing is let's get a man out into space, because it was, we needed to get humans out there. And of course, that was also part of the space race, and the Soviets were basically on a roll, and they beat us to doing that one as well. They surprised the world in 1961 when they launched Yuri Gagarin to space on a Vostok 1. He was the first human to enter space, and he went around, orbited the world, and came back to Earth, and he was probably one of the most famous faces on the planet for quite a long time. Both the Soviet Union and the United States began developing ever more powerful rockets at this point to get to the moon. That was the big thing we had to do, was get to the moon. The rocket that ultimately did take people to the moon was the Saturn V, the great-grandchild of V2. And it flew, and von Braun and his people made many, many refinements. Many people worked on this to get it up there, and for some people, it's probably the finest rocket ever built. I've seen, I don't know how many arguments on the internet, on the web, on Facebook the last 3 weeks with people saying, no, it's actually the Falcon Heavy, that's the best rocket ever made. No, you're wrong, it's actually the Saturn V, that's the best rocket ever made. To me, they all seem pretty powerful. I mean, I know how powerful they are. I just love watching them launch.
Wasn't the Energia more powerful than the Saturn V though?
No,
No? Saturn V
no,
more
Saturn
powerful?
V is 140 tons to orbit, Energia was 90.
Yeah.
My apologies.
Falcon Heavy is 60.
Good thing we have Zuber here to prove you.
Yes. Well, thank you. He said what I was going to say anyway. It's a huge argument. I mean, people, I think we all like things that go boom and are really loud and launch off this. Every time I watch a launch, I'm practically in tears. They're so beautiful. Falcon Heavy just totally blew me away. I couldn't believe how great that was. I did not ever get to see a Saturn V launching, so I could ever just see those on television.
Hey, Carolyn,
Yes.
why are people arguing about this? I mean, Falcon
Why
9
does-
Heavy is 50 years after the Saturn V.
Why do space people argue about anything? I mean, I think a part of it is a generational thing, but not always. I mean, all the SpaceX guys, all the SpaceX fans come on and, Elon can do no wrong. On the other hand, you have a lot of people that look back in history and go, well, von Braun did some good stuff too. Von Braun wasn't running a company. It didn't capture the imagination. It captured the imagination, but in a different way. And I don't know. I mean, I'm watching this going, they're different rockets. They did different things. They're going to do different things,
You said generational thing, I think that's a lot of that.
Well, I don't mean to be insulting, but... All right, anyway, so since the time of Apollo, we've seen rocket development continue not only in the US and Russia, but also in China and Japan, India, and many other countries. You were just talking about New Zealand, the company that's doing that. It totally blows me away, what they're doing, and they just are dependent, they're just determined that they're going to, be launching for everybody. They want to be like the people's launch company. But we've also seen the rise of commercial rocket companies like Rocket Lab. And so we have, SpaceX launches, which we've just talked about, and the return of their first stages to Earth. Now, when the Falcon Heavy stages came back, that was just like, to me, that was like watching science fiction come true. How many of us read Heinlein or whatever, and rocket ship Galileo or whatever, and this thing comes down and lands, and everybody gets off and goes off and does stuff. We didn't get to do that until relatively recently. So to me, that's just a really miraculous bit of work that they were able to make that work. And then also Blue Origin is another one. We're going to see that launch tomorrow. And then Rocket Lab, as I mentioned before. And the Arianespace. I don't want to forget those people. They're developing heavier and better rockets as well. This is probably having the battery run out. There we go. Let's go back. In India's space program, how many of you have been following that? Every time they have a launch, and if I write about it on my blog or on Facebook, I get these private messages from people in India saying, oh, thank you, beautiful lady, for writing about our space program. You want to send me presents. No, to India, this is like, we've become the big boys. We've joined the big boys. We've joined the company of nations that go to space. And they're really, really proud of it, and they should be. You know that their first mission to Mars was their first try, and they made it. You know how many other times everybody else has tried and we've had all kinds of problems? They made it. Of course, they were able to build on what they learned from the rest of us, but they made it. And to look at the faces, when that thing went into orbit, when the Mars orbiting mission went into orbit, and they had their prime minister there, and he's talking to people about this was a big, big deal. And I wrote one little short article about it, and then I immediately had to expand on it because I got probably 100 messages from India in one night. It's pretty amazing. All right, so today's space exploration is a worldwide activity, as we can see. This listing is probably out of date. I'm probably going to have to revisit it. Every one of them with a star in front of it, the name has a star in front of it, has launch capability or has some kind of space capability. Those with orange and with a star also have space flight capability that can take humans out to space. Now, the United States probably should have 2 stars cited right now because we're not quite there doing it on our own, but we will be. You can see it's a fair approximation of the United Nations that's going to space. All of this is thanks to really an ages-old fascination with lobbing rockets and fire arrows at one's enemies, and I think that's pretty interesting. All right, now I want to turn I know I could go into rockets for hours. I mean, they're fascinating, but I want to turn to another aspect of this, and that's education and space exploration. Space exploration has affected our society, even as our society has been making space exploration possible. And in the early years of the space age, particularly in the US, there was a huge push for more science education. And I grew up at that point, so I didn't know there wasn't a big push before that. And I asked my mom about this, and she said, well, we had biology classes, we had chemistry, but you didn't really have a heavy physics unless you were going to go be an engineer. You didn't take it. Or if you did, maybe you were going to be a doctor or something like that. But just regular run-of-the-mill kids were not taking the heavier sciences, and there was a big push. Part of the reason for that was that we needed more scientists, we needed more engineers, we needed software programmers, we needed people to help loft those rockets into space. And NASA needed it like right now, so they started pushing for more and more education, not just in colleges where they needed it, in the military, but also in the lower grades as well. And so in order to be able to create the hardware and the astronaut suits and all the things that we needed, they needed to really push science education. So the National Space Science Foundation and other agencies were tasked with building science curriculum for the schools. Now, I kind of remember this because I started school in 1959, and I remember that I grew up in Boulder, and Boulder was space mad. It had the National Bureau of Standards, it had the university, it had Ball Aerospace. I don't think it was called aerospace at that time, but it had Ball.
Rocket Research.
Ball what?
Ball Rocket Research.
Ball Rocket Research. And my dad worked there when it became, like a few years later, they were bringing home pictures of orbiting solar observatories and things like that. But it was this space mad city, and so we were all kind of expected we were going to study science and then go up to university and do it again. When astronauts launched, particularly Scott Carpenter, they came back and went down Pearl Street, and we all waved at him. It was space mad. I remember that. I was down there and going, I think he looked at me. This is so cool. So, the National Science Foundation created a lot of ability for people to teach more science. It's now grown, and this is not just from NSF, but from other agencies, to where students can participate in space missions, even as young as elementary school. Am I in your way? Sorry. All right. This has been made especially attractive by the rise of CubeSats and nanosats in recent years. Kids working with scientists can send things to space. Now, it's mostly, I have to admit, it's mostly college and high school students, but there are kids who do it as well. This is a group of students at a school in Virginia called St. Thomas More Cathedral School, and they built a CubeSat that I believe that theirs was the one that was based on a smartphone technology, and they sent it up there to be able to sense atmospheric changes in the atmosphere. And they're watching as their spacecraft is being deployed from the International Space Station. And you look at these kids, they're not junior high. Or that, some of them are junior high, some of them are middle school, and there's some younger ones in there. This is a group of kids that worked for months, probably more like a couple of years with scientists at NASA to be able to build and deploy a spacecraft. And that's not something I could have done in 1959 or 60 or even 69. So I thought that was a very interesting effect of having a space program. This happened in 2015. Student interest is not just limited to the students who are in college. Graduate students can go and learn, get involved in space exploration. This is a group of students learning how to training how to run spacecraft at the European Space Agency Training Center in Europe. Now, when I went back to school in the late 1980s at the University of Colorado, I actually was offered a choice. I was going back to do some undergraduate work prior to applying to graduate school. And I had an opportunity to apply for a couple of jobs, and both of them were through the Laboratory for Atmospheric and Space Physics. One of them was to control spacecraft. There's a spacecraft control center down in the LASP East building. And then the other one was to work on Hubble Space Telescope. And I kind of applied for both of them, thinking, you know, if I don't get one, I'll get the other one. And sure enough, I got the Hubble Space Telescope one. But in the meantime, generations of students have gone down and they've learned how to control spacecraft at last. I spent a number of years on the Hubble Space Telescope instrument team. It was for Goddard High Resolution Spectrograph. Some of my office mates worked on solar observing missions, watching long-term changes on the sun. They controlled satellites, and they were doing fundamental research on distant stars, all using data from spacecraft. So that, again, if somebody told me in 1959 or even in high school, you're going to be working with spacecraft data to do science when you're in college, I'm not sure I would have believed it, but we've come that far. We've come so far from saying, let's have more science in the schools, to let's let students control spacecraft, which I think is pretty cool. So this, again, is a group of college students working at ESA headquarters, learning how to control spacecraft. Come on. Oh, I might have to, oh, here we go. You know, you hit this thing, it's like ketchup coming out of a bottle, you know? All right, here we go. So, recent missions that have, there are many other missions that have a University of Colorado touch, and they range from the New Horizons mission, which you've all heard about, that went to Pluto. There's a student dust counter on there that was built at the university, to the Mars Maven mission, to the Juno probe at Jupiter, Voyager missions to the outer planets had University of Colorado touch. And I'm sure many other future missions will happen with CU as well. And I bring it up because it's right down the road, and I'm really proud of being able to go to school there. CU is only one of many places that does this. You see students from MIT and Harvard and Caltech and Texas and just all over the place learning how to be, basically how to be space scientists. Caltech has contracted with NASA's Jet Propulsion Laboratory to do quite a lot of research work, and they supply their students there. Harvard students work on the Chandra X-ray satellite, which has been showing us an X-ray view of the universe for quite some time. Universities and colleges are really fertile gardens for people to go and learn this, and so I urge any of you who want to send your kids to college to do this, that CU and other schools are great places to do this, and there's a future in space science for them. Now, another thing that I want to bring up in education and space science is the rise of planetariums. You guys all been to a planetarium? Well, Mark and I work a lot with planetariums. We create planetarium shows that we sell around the world, but both of us also got our start in planetariums down at the Fisk Planetarium in Boulder. And so we naturally got kind of interested in the history. And for this book, I decided I wanted to talk a little bit about that, because planetariums in people's mind are space. If you want to go learn about astronomy or space, you know, in a sort of an informal outreach way, you do it at the planetarium. Now, the first modern ones have been around since about the 1920s in Germany, and those were the early Zeiss machines. And so the first one in the US was built in 1930 in Chicago. Others were built later, and what I wanted to point out, this is the Adler Planetarium on the left here, and on the right is a little sign at the Moorhead Planetarium in North Carolina, talking about how Moorhead Planetarium trained NASA astronauts for celestial navigation for Mercury, Gemini, Apollo, and Skylab missions 1960 to 75. And they're very proud of that, and they should be. I understand that Griffith Observatory also trained astronauts as well. That is another reason why planetariums became in the public eye for the places to go learn astronomy. These heroes that were going into space were training at planetariums. And we sent our kids to go look and learn at the planetarium how to find things in the sky. So, wow, this is really slow. Come on. Is it going to go? All right. So in the early 1950s, well, I'll come back here. Come on. All right. In the early 1960s, there was a push to build planetarium instruments in the United States. And I'll backtrack a little bit on this in a minute, but people wanted a United States-built instrument that didn't cost a fortune. So a gentleman named Armin Spitz started building things, and this is his first Spitz A1 projector that he built, and those were soon in many, many schools. In fact, in Pennsylvania, there was a rule passed that every new planetarium, or every new, I think it was high school, had, what was it? School district had to have a planetarium. So you ended up with like 300 planetariums in one state. Spitz handled the demand for quite a long time. Also being sold in the United States were the Zeiss instruments as well as some others. So the Carl Zeiss Company led the world in optomechanical planetarium instruments beginning about 100 years ago, so in Germany. They also build lenses, telescopes, glass for microscopes, binoculars, that sort of thing. So they do a really good job. We've actually visited their Jena facility in Germany. This shows, the first one on the left is the Wonder of Jena, and then the one in the middle is the Mark VI, which is what we trained on at the university. And then in the right is what it looks like now. It's more of a star ball. But the reason that we started seeing the sale of other instruments in the US was during the war. Well, you couldn't get those instruments during World War II. At the end of the war, Zeiss was actually split into two companies. One half went on the East German side, one half was on the West German side. The United States could own the wall. And there's some kind of interesting stories about all these old optical engineers getting together after all the years that the wall was up, and they're both working on both sides, and they get together and they realize they were basically doing parallel development of planetarium instruments on each side of the wall. Now, also in the United States and around the world, the Goto and Minolta companies created planetariums. Minolta is now Konica Minolta. And the reason I show you all these is that the market for planetariums continued to grow for a long time, partly because of our interest in space, partly because of the influence of space exploration. Modern planetariums are more likely today to be built with video projection systems. Here you see me with a Digistar system. This is made in Salt Lake City. And these use large databases of stars and other objects to recreate the starry sky on a dome. And a lot of times they're also installed with a star projector, if somebody wants that as well, the optomechanicals. So today there are about 4,000 planetariums around the world. Most of them are converting to this, what we call full dome video. Some of them will keep their star projectors if they can. They see about an estimated 152,297,583 people per year around the world. This is Mark's number. He created this. Give or take, yeah, like 3 or 4, give or take. About 2/3 of the facilities are in schools. The rest are about evenly divided between universities and science centers. And they do anything from live presentations to full dome videos to weddings to, you name it, they do it in there, but largely it's space oriented. And a lot of times we see new full dome films come out that are not space oriented, and we kind of wonder if they're going to sell because people associate in their minds space with the planetarium. And they're a huge part of space interest around the world. As I said, planetarium shows range from live shows to fully rendered. I'm just going to show you some little one frames from some of them. They cover topics from space exploration and astronomy to, and these are both shows that deal with going to Mars. The one on the left is from a show we did called Mars Quest. The one on the right is a scene from inside the cockpit of a ship going to Mars from a new show that we have called Explore. And so Mars is kind of a big thing right now. There are several shows being created about going to Mars. But we also have kids shows. So one of our most popular shows is called Larry Cat in Space, about a cat that goes to the moon. And that show continues to show a lot of places. I keep running into people at planetarium conferences who went to school, saw this show, went to college, got a job in the planetarium, and they're now showing it. So it's got this multi-generational appeal to it. And then, for some reason, the Adler people at the Adler Planetarium and the Beijing Planetarium, and the third one was Carnegie? Liberty Science Center, got involved in creating a show using the Sesame Street characters, and it's called One World, One Sky, and it's for little kids. And so we actually sell, a number of people sell that show, and it's been running all around the world. So it's a big thing for kids. In fact, in Japan, we've been told that planetariums are considered largely for kids. All right, there are also music and art shows. It's really become a way for planetariums to bring space to people and to bring space-related and space-influenced art and music to people as well. So the one on the left up here is from a show called Musica, which looks at physics of sound by way of music. And then the other one is a show called Chaos and Order, a Mathematics Symphony. And it's all about, it's basically animated mathematical sequences. It's really very cool. And I looked at it the first time, I said, where was this when I was flunking calc the first time? It's such a cool show. It helps you visualize these mathematical functions. Well, we're obviously all aware, aside from planetariums, of the influence on movies, of space on movies and other art. And 2001 is, the 50th anniversary of 2001: A Space Odyssey is this year. And there's a story in a recent copy of The New Yorker that Stanley Kubrick was saying he was watching the space program very carefully when he was making this movie because he was afraid that his movie was going to get scooped by real events, that something would be found. So he was really, really worried about that. If you guys read The New Yorker, it's actually a great story to read. The movie is actually based on the ideas that were written about by science fiction writer Sir Arthur Clarke, in a story called The Sentinel. And it's about people on Earth finding this thing buried on the moon, and it gives off a signal and obviously is letting an older civilization know that people have gotten space flight capability. So if you go to this movie or you read this book, you see an awful lot of influence from space exploration on this. Clark first came up with the story actually back in the 40s, but he was also very well aware and very prescient in noticing that we were going to be going to space someday. I'm just waiting for this to change. Come on. It's going to do it really fast. So here we go. Hold on. Go back one. Oh, that's right. All right. Now, there are other movies and TV shows that we all know about that have been influenced by space. And obviously, we've got Babylon 5 and Battlestar Galactica and Star Wars and Star Trek. I started out as a Trekkie. I remember going to see 2001 with my dad. It was sort of the first serious movie we'd ever seen together. And afterwards, we went for coffee and we just stared at each other for about an hour. Like, what is this about? But we were both Trekkies too. We'd been watching Trek ever before this ever came out. But there's much more that that science fiction has done. There's been sort of a cross-fertilization between science fiction and space exploration. Come on. What? I'm going to have to do that. The whole realm of science fiction literature, which really began back in the 1800s, has been based on and influenced by, in a few cases, and also influences space exploration. It's often been called the history of the future, and I always kind of like that, because it takes its cues from things that are going to happen in the future, but with a historical look. Particularly in post-war years, we saw the great rise of science fiction from the advances of space exploration. So you look at the grandmasters of science fiction, such as Robert Heinlein or Arthur Clarke or some of the others, have taken us to the moon, they've taken us to Mars in our imaginations and beyond, all through their stories and books. And I don't know how many of you here read science fiction, but I've been reading it since I was about 7 or 8 years old. In fact, the first time I went to take a science fiction book out of the library, the nun behind the desk said, "Oh, that's for boys." Yeah, that's what I said too. I made this joke the other day, and I told her, well, she's dead now. And then I realized they thought I killed her, but that's not the case. She was just really old. All right. So the other thing about space exploration is it's given us is technology of the future as well. And some of it seems to come straight from the realm of science fiction. If you think about 2001, for example, we had the space pad. I remember seeing that, his news pad, where he's reading the news on a pad. And then not too long ago, I was in the hospital, and I took my iPad along to read after surgery, and I realized, I've got a news pad. It's the same thing, it's just a slightly different shape. And also, you think about Star Trek, the communicator. I always wanted one of those when I was a kid. I've got to have this communicator. Now I have a communicator right here. It doesn't quite look like that, but it's there. Okay, I didn't say here. Oh yeah, I did have a flip phone. Yeah. So here today is the modern iPad, and then we've got the flip phone. I think I did have the first Motorola flip phone, and the reason I bought it was because I saw Patrick Stewart had one, and we were in a studio recording Patrick Stewart, and I saw him, and he said, "Would you please watch my phone for me?" And I said, "Of course." And then I sat there and watched it. And then the minute I went home and I needed a new phone, I said, "No, I want to get this thing," and I had it for quite a while. But now we all have iPhones and smartphones, and we don't flip them. There are still flip phones, I noticed that. So anyway, we all communicate around the world using these things, or we use Skype or whatever. We're just doing things that wouldn't have been possible without space exploration. And then there's space art. You guys remember that when we had Michael Carroll come here and speak? Well, he's one of the better known space artists. He does quite a lot of that. I also have other friends who do space art. We've hired them for our planetarium shows. The cat picture on the left here is by a gentleman I know in England named Stuart Atkinson, and he photoshops his cat over every space scene he can find. She's a beautiful cat, too. And then the one on the other side here, there's a gentleman named Ryan Bliss who runs Digital Blasphemy, and he puts out all this great space art. If you ever want to go get some, you can get a $25 membership, I think, for a year, digitalblasphemy.com. And I don't get a kickback from this, but he just does great work. So space art has sort of brought us all out into the realm of space as well, influenced by space exploration. And then space music, which we've talked about and you heard and you will hear. Mark started doing space music back in the 1970s. Do you want to admit you're that old? And has been doing it ever since. He's got 13 albums out there. And it really was to put in the planetarium and make people feel like they were out in space. Not with any kind of Earth-based instruments, because we all knew from what space sounded like in 1967 or 69, didn't we? It was the Blue Danube. That's Earth-based instruments. He was starting to make other instruments that would make us sound like we were in space. And there are other space artists out there. So, it's been a long road from the first fire arrows to the space exploration that we're all experiencing today. There are many, many, many other things I could have talked about. There are laws, there are treaties, there's commercial rules, there are commercial developments, there are whole universities that are basically now doing nothing but space education. But behind all of this, the rockets, the spaceships, the laws, medicine, I mean, all these kind of things, the buildup of space commerce is also happening. But we also need the human side of the equation, and that's a really important part of building a space civilization. The people, the art, the music, the brains, the ingenuity, the imagination that we have to think about going to Mars, to think about what we're going to do once Bigelow puts his thing out around the moon or wherever he does this. What are we going to do with these things, and what are those people going to be like that live on the moon and Mars and the space stations? They're not going to be quite the same humans we are. They're going to have different art and music and outlook and laws and a whole different way of life, and they're all going to be coming from us. And so those are the things that we have to think about when we look at a history of space exploration and also what it takes to build a spacefaring civilization. Now, someday I'd like to think that there's going to be a space station that looks like this out there somewhere. Maybe not with a nebula right behind it, but somewhere out there. And it's going to be straight from the realm of science fiction. But it's going to be something that we built because we saw it in science fiction, we saw it in our imaginations, and we built it to go out there. And it will be as real as any spaceship that we have today. And it'll be populated by that new breed of humans that we're going to be creating, that we have already created. Maybe you will be one of them, or someone else very young in this room will be one of those people taking that first step onto Mars. And this is, after all, where all of the elements line up, in the human heart, in the human brain. Whether or not we use those to build things for war or for rockets, that's really the influence that we have on going to space. And these are the things that we want to think about as we continue to go out farther into space. So I think with that, I'm going to say thank you and ask you if you have any questions.
Turn up the lights a bit.
Have any questions?
Questions?
I can stand up for that. Yes.
I'm just curious about what your timeline, or what your thought for a timeline is as far as leaving our solar system.
Leaving the solar system? Well, we already have spacecraft leaving
as far as
humans.
humans leaving the solar system.
You know, it's going to take a drive to really want to go out that far. And I was talking to somebody about this not too long ago, that maybe what's going to happen is we're going to have to send people out to Pluto to look at that, and then they're going to want to take that next step out there. I can't see it happening within the next 100 years, to be honest. We have to get to Mars first, you know, or wouldn't it be cool to send somebody to Europa? You know, but we just don't have that yet. So I'm hoping, and Bob, maybe you can back me up, we have humans on Mars in a decade.
We can if we decide to do it.
Yeah.
But that's the key question.
Oh yeah, and I didn't mention the politics. Politics is a whole other issue of going to these places. But as for going to Alpha Centauri, I just don't see it happening in a century even. It's going to take some technologies we just don't have yet.
But you're studying astrophysics, is that right?
Yeah.
So what do you think?
Well,
How are you going to get us out there sooner?
I've gotten different opinions. I read
Yeah.
Michio Kaku's book on what he thinks the lifetime will be, and he says upwards of 1,000 years before we're a spacefaring civilization. And I mean, I guess it's just a curiosity of mine to kind of look forward to.
Well, in my book, I don't go farther than, well, I did mention things like Alcubierre drives and faster than light drives because the editors asked me to, but those things don't exist yet. And what? But I did mention that we would go to Mars, and I really see that as the next big step. Yeah, we might make a step to the moon first, or low Earth orbit, or whatever. But Mars really seems to be kind of up on everybody's main board at this time, and that's going to take a while. Yeah.
With our current technology, doesn't it take, or wouldn't it be like a 4-year trip to Mars?
No.
No,
6 months.
6 months?
Yeah, months. Yeah.
One way or?
One way is 6 months.
Yeah.
For instance,
Yeah, then you-
InSight is going to launch next in a week, and it will be at Mars in around November.
Yeah, it's late November. Yeah. So the deal is you're going to go out there, and then you've got to think about how long you leave your crew out there, because you have orbital mechanics to think about. Mars will have moved along they need to be able to get back to Earth in a convenient, quick way as well with, the least amount of fuel. So that kind of determines how long you leave people on Mars. They might stay a long time. I honestly hope that they don't stay the rest of their lives like the Mars One people seem to think they should. I really would like to see them go and establish whatever they need to establish, and people that want to come back, but we continue to send more people out there. That's been my dream for a long time. I wanted to go to Mars. I might be lucky if I get to go to the moon at this rate.
Yeah. So how soon? How soon will we have humans on the moon? Because Leonard wants to know, he's working on this.
Yeah, what does Leonard say?
That's also a question of if we decide to do it or not.
Yeah, well, and it won't be our country, it'd be international, right? Or somebody else, or Elon Musk, or,
Well, I mean, look, the phenomenal
Let's just
thing
go.
is here you have-
Maybe Skywatchers can get us. Come on, you guys.
Robert?
A rocket? Who volunteered? No, okay.
I mean, it poses a question. I mean, here, okay, Kennedy made his speech in 61, we were on the moon in 69, it was 8 years. Right now, and we didn't even have push-button telephones when we launched that program, okay? And now, your Trump administration says, oh, we want to go to the moon, and if you actually then look at the program, they talk about landing a robotic lander on the moon in 8 years or something.
Yeah, and this is not new. This is not new.
And there's no question of it being feasible because we did it half a century ago. And
And the Chinese have done it.
so the issue of whether the government can do it or not is a question of whether the government has become senile or not. And then, so now you have then the other option, which is Plan B, which is the entrepreneurs to do it.
Yeah.
We'll see.
Yeah, Mark, did you have a
Just who
question?
wants to pay the price tag? It's expensive.
Yeah.
That's it.
Mark, did you have a question?
Technology sector.
In my view, we always had the space exploration goal of government, NASA, all of America, versus the Soviet Union. Certainly possible that a private company is going to land on Mars within the next 10 years, and that's not us, that's a private company.
That's sort of the wild card right now, I think. Although, I mean, Elon keeps saying he wants to send people out there. And the people to watch are also China and India. They've got big plans. How well they're going to be able to do those is another question. Anybody else? Yeah.
So there again, if we decide to actually do it, if we establish like those colonies on Mars and the Moon, do you think that they'll actually become like the basis of basically everything after that? We're going to be sending those missions from those points, or are they going to continue being from?
Oh, you mean, okay, so that's a really good question. I mean, a long time ago, when Robert and I were both going to Case for Mars meetings, actually, so back in the 80s, when your mom was a teenager. Anyway, we were talking about staging from the moon. That was one possibility. We go to the moon, do what we have to do to get our spacecraft going, and then we all go out to Mars. We didn't really talk beyond Mars. And so right now, I don't know that there's the infrastructure plan to send people farther out from Mars. I've seen, a few kind of interesting studies, but nothing really saying, okay, we're going to use Mars as a jumping off point. Once you get off of Earth, then you're sort of out of the gravity well, and you kind of go where you want to go. It doesn't necessarily mean you're going to be closer to Jupiter from Mars. It depends on where it is in its orbit. I just like us to get out there. Anybody? Yes?
You said that you want to use the moon as like a jumping off point to get to Mars. I guess it is what you were talking about before, but
A staging area.
Or a staging area, yeah. So how do you feel about that as far as like lack of resources available to it? It seems like it would be a useful thing to get away from the gravitational pull of the Earth at least a little bit.
Yeah.
But the lack of resources available to.
Well, the other thing too that we used to look at was staging everything in low Earth orbit or farther out. So, but you're still basically bringing up everything out of the gravity well to build your spacecraft or whatever. One thing that we talked about for a while was build stuff from resources you can find on the moon, not knowing what the resources were going to be.
Well, the thing is this, sure, it's easier to take off from the moon than the Earth, but before a spacecraft takes off from the moon, it has to get to the moon, which means it has to take off from the Earth. And it's actually easier to go to Mars directly from the Earth than to go from the Earth to the Moon to Mars, even if you had free fuel on the Moon.
Yeah.
But there's a different answer that I give your question, which is this, which is not whether we'll send spacecraft to Mars and refuel them and then go on from there to Jupiter or something, but rather, if we go to Mars and settle Mars and create new branches of human civilization on Mars, so that they are in fact manufacturing spacecraft on Mars along with all sorts of things. And I think there's a real chance that it will. I mean, look, if you think about it, European explorers of America and settlers to America, in particular to North America, for example, settled the East Coast. The people who then explored the Middle West came from the East Coast. Okay, they didn't come from England. Okay, and the people who settled California, well, some of them came from the East Coast and some came from the Midwest. Okay, so yes, the frontier advances, and in fact, Daniel Boone decided to move from Kentucky to Missouri because when someone moved within 10 miles of his cabin, it got too crowded. And
We can relate to that up here, you live down there, but.
Yeah. But what I mean is you
Those
get
of
a
us who
certain
live in-
mentality of people who want to be on the frontier, and as the frontier is settled, it is no longer the frontier, and they have the desire to move on.
Yeah, Robert's absolutely right, and the thing that you're saying there also reminds me that, what I've been thinking about lately is what's that civilization going to be like on Mars? Not just sort of in a general sense. They're going to be a different breed of human than we are because of a different world that they're going to have to get used to. And I'm hoping that they are really going to want to do that once they get settled in there and are able to build their manufacturing facilities. I see that.
Right, but you see, here's the thing. Europe has a bigger population and economy than the United States, but the United States space program is much bigger than the European space program. And in particular, the manned space program is, or the piloted space program. Okay, and why is that? Okay, and because Americans miss the frontier. No, it's true. And even the word frontier, frontier is actually a French word, okay? But in France, the frontier is like the border with Germany. And no American, no, that's what they call a frontier. But no American would think of that as being the frontier. The frontier is the place beyond which the rules haven't been written yet. And we miss that place. We think a future without a place where you can go where the rules haven't been written yet is not an adequate future. And that's why America is pushing the space frontier. Yes, you can point, we get weather satellites, we get this and that, but that's actually not why Americans support the space program. They see it as the vehicle for getting us to that new frontier.
Yeah, it's a mentality that continues even after 400 or 500 or 600 years. That we want to move forward and do things. Let's take one more question, and I guess we should. Yes, back there.
I'm just, clearly I'm behind on my Mars space program, but somebody explain, like, if I take a Falcon 9 and put it on Earth versus a Falcon 9 and put it on Mars, what's the fuel consumption to get into orbit and theoretically slingshot off of orbit to somewhere else? Is it significantly better to launch from Mars if we're able to build stuff there, or would it be
If
easier
that
to
were,
just launch from Earth?
within the limits of that question, your answer is yes. The orbital velocity of Mars is like 4 kilometers a second. The orbital velocity of Earth is 8 kilometers a second. And so it's only half as much orbital velocity, it's half as much escape velocity. The amount of propellant needed to achieve these things is exponential with the change in velocity done. So yes, if you're simply asking, is it much easier to reach orbit from the surface of Mars or reach interplanetary trajectories from the surface of Mars than
Yeah.
Earth? Yes.
Any further from the sun when you start, so you get away from the sun.
That's right. Yeah, there's a number of factors that make it much better for Mars. Just we have to be able to build it there to do it.
So if we're able to build our spacecraft on Mars, it would be a better jumping off point than Earth. Just
Yes.
From getting
Assuming,
into
assuming you have the same resources, you build the same things.
Right.
Yeah, all things being equal, yeah. I mean, other than the atmosphere and stuff like that. All right, well, thank you all for coming, and I'm happy to stay up. Thank you, Robert, as well.
I'm not sure we've heard woo-hoo.